Differentiating quadratics. The equation of a quadratic graph takes the form y equals ax squared plus bx plus c. Now, we can differentiate a function with more than one term by differentiating the terms one at a time. So, I've already covered about differentiating x to the power n and ax to the power n in my previous Pure Maths video. If you want, check it out for more details. Now, to differentiate y equals ax squared plus bx plus c, the derivative is given as dy over dx equals 2ax plus b. So, as I said earlier, we can differentiate a function with more than one term by differentiating the terms one at a time. So, in y equals ax squared plus bx plus c, we can get this expression for dy over dx by differentiating each of the terms in y equals ax squared plus bx plus c one at a time. Now, first let's take ax squared. So, differentiating ax squared gives us 2 times a times x to the power 2 minus 1 equals 2a times x to the power 1 equals 2ax. So, here we multiplied the constant a by the power 2 and subtracted 1 from that power. Now, let's differentiate bx. So, here the power of x is 1, let's say bx to the power 1. Then, differentiating this gives us b times 1 times x to the power 1 minus 1 equals b times x to the power 0 equals b, as x to the power 0 equals 1. So, as you can see here, an x term differentiates to give a constant. So, in this case, differentiating bx gives us the constant b. Now, differentiating c gives us 0. This is because constant terms, in this case c, disappear when you differentiate. Then, the derivative dy over dx of y equals ax squared plus bx plus c is 2ax plus b plus 0 equals 2ax plus b. Now, let's take a look at a few examples. Find the derivative dy over dx when y equals 2x squared minus 6x. Now here, since we have more than one term, we have to differentiate the terms one at a time. So, let's start with 2x squared. So, to differentiate 2x squared, we multiply the constant 2 by the power 2 and subtract 1 from that power. Then, 2 times x to the power 2 minus 1 equals 4 times x to the power 1 equals 4x. Now, to differentiate minus 6x. So, here the power of x is 1, then to differentiate, we multiply the constant minus 6 by the power 1 and subtract 1 from that power. So, minus 6 times 1 times x to the power 1 minus 1 equals minus 6 times x to the power 0. X to the power 0 equals 1, then minus 6 times 1 equals minus 6. So, when y equals 2x squared minus 6x, dy over dx equals 4x minus 6. Now, y equals 1 over 2x squared plus 12x. So, here, to find the derivative dy over dx, we can start by differentiating one term at a time. So, starting with 1 over 2x squared, differentiating 1 over 2x squared gives us 1 over 2 times x to the power 2 minus 1. As we multiplied the constant 1 over 2 by the power 2 and then subtracted 1 from that power. So, 1 times x to the power 1 equals x. Now, to differentiate 12x. Here, the power of x is 1, so let's say 12x to the power 1. Now, to differentiate, we multiply the constant 12 by the power 1 and then subtract 1 from that power. So, 12 times 1 times x to the power 1 minus 1 equals 12 times x to the power 0. X to the power 0 equals 1, then 12 times 1 equals 12. And hence, the derivative dy over dx when y equals 1 over 2x squared plus 12x is x plus 12. Now, let's take a look at a few more examples. Y equals 8x squared plus 7x plus 12. As we have more than one term to differentiate, we can start by differentiating one term at a time. So first, taking the term 8x squared, to differentiate 8x squared, we multiply the constant 8 by the power 2 and then subtract 1 from the power. Then it's 8 times 2 times x to the power 2 minus 1 equals 16 times x to the power 1 equals 16x. Now, taking the next term 7x, here the power of x is 1. So, to differentiate 7x to the power 1, we multiply the constant 7 by the power 1 and then subtract 1 from that power. Then it's 7 times 1 times x to the power 1 minus 1 equals 7 times x to the power 0 equals 7, as x to the power 0 equals 1. Now, taking the final term 12. So, as I said earlier, constant terms disappear when you differentiate. So, here, differentiating the constant term 12 gives us 0. Then the derivative dy over dx when y equals 8x squared plus 7x plus 12 is dy over dx equals 16x plus 7 plus 0 equals 16x plus 7. Moving on to another example, find the derivative f dash x when fx equals x squared minus 2x minus 8. So, we can start by differentiating the terms one at a time. So, starting with x squared, to differentiate x squared, we multiply by the power 2 and then subtract 1 from that power. So 2 times x to the power 2 minus 1 equals 2 times x to the power 1 equals 2x. Now minus 2x. Here the power of x is 1, so let's say minus 2x to the power 1. Now differentiating minus 2x to the power 1 gives us minus 2 times 1 times x to the power 1 minus 1 as we multiplied the constant minus 2 by the power, in this case 1, and then subtracted 1 from that power. So minus 2 times x to the power 0 equals minus 2 times 1 as x to the power 0 equals 1. Then it's minus 2. Now differentiating minus 8 gives us 0 as constant terms disappear when we differentiate. So when fx equals x squared minus 2x minus 8, the derivative f dash x equals 2x minus 2. Fx equals 4x squared minus 8x plus 3. To differentiate this function with more than one term, we can start by differentiating the terms one at a time, starting with 4x squared. So to differentiate 4x squared, we multiply the constant 4 by the power 2 and then subtract 1 from that power. Then it's 4 times 2 times x to the power 2 minus 1 equals 8 times x to the power 1 equals 8x. Now minus 8x. Here the power of x is 1, so let's say minus 8x to the power 1. Differentiating minus 8x to the power 1 gives us minus 8 times 1 times x to the power 1 minus 1 as we multiply the constant minus 8 by the power 1 and then subtracted 1 from that power. So minus 8 times x to the power 0 equals minus 8 times 1 equals minus 8 as x to the power 0 equals 1. Now taking the final term 3, differentiating 3 gives us 0 as constant terms disappear when differentiating. Then the derivative f dash x when fx equals 4x squared minus 8x plus 3 is 8x minus 8.